Splendid! There is only one string left for us to discuss. With header strings, we see that it is address state. Just as usual, we start by displaying its contents. Please note that since we've just removed the URL column, address state is now occupying the 5th index position. We see several different two-letter abbreviations of different American states, like California, New York, and Pennsylvania. If we check the unique values, we'll see an array which starts with an empty space, and then the different abbreviations of various U.S. states in alphabetical order. If we refer to the size attribute of this output, we'll see that there are 50 different values within the column, which is fantastic because there are exactly 50 states in the USA, right? Well, not really. We also have the empty spaces included here, so there's no data from exactly one state. We won't go over all the unique values one by one right now, but the missing state is Iowa. We suspect that it was purposefully left as a baseline benchmark. This shouldn't come as a big surprise. When doing research or analysis on a variable with many categories, it is normal to pick one as a benchmark and include dummy variables for the rest. With such an approach, the one without a dummy variable will serve as the base case, and we will either increase or decrease the rest based on their coefficients. In our case, we'll assume this was Iowa. We can also see how many times each state features in the column by setting the return counts argument to true. We see that for every state in the first array, there is a number of appearances in the second array. However, the values are sorted according to the alphabetical order of the state names, rather than the number of applicants. Since it's harder to extract any insight from this, let's combine NumPy's unique and argument sort functions to display the states according to the number of applications in descending order. For starters, we can use tuple assignment and store the two arrays we see on screen into two new variables, states names and states count. Then we'll use argument sort to find the indices which will sort states count in descending order. We will store these in a variable called states count sorted. It's important to remember we need to add a minus sign within the parentheses because we're sorting in decreasing order. After we're done, on the same line separated by a column, we can call states names and states count and plug in states count sorted as the index. This should display each variable according to the sorted indices we'll get from the argument sort function. If we run the cell now, we'll once again see the two arrays we had before, but this time the states are arranged according to the number of applicants from each one. Unsurprisingly, most of the accounts come from highly populated and wealthy states like California, New York, Texas, and Florida. In fact, we see that these are the 4 states with more counts than the empty space we see in position 5. Hence, there are more applications with missing or unreported addresses than there are for 45 of the other states. Therefore, we have very little data for too many states to examine each one individually. With that in mind, if we assign a unique value to each state, as we did with subgrades earlier, this will allow outliers to have a big influence on the coefficients for less represented states. To elaborate, the more categories a variable has, the fewer data will be available for each one. As a result, the states with fewer applications will be more vulnerable to have their coefficients affected by outliers. To solve this problem, we need to group these states according to a certain common characteristic. One way around this is to think of their geographical location. The 4 regions will be as follows: West, South, East, and Midwest. Before we apply this idea into practice, as usual, let's take care of missing values first. We'll use the where function and pass a value of 0 to every empty space in the column. This way, accounts that can't be attributed to a specific state won't be included in any region to avoid biasing with variable coefficients. All right, we'll start by creating 4 arrays, one for each of the 4 regions of the USA we mentioned a minute ago. We'll call them states West, states South, and so on, based on what part of the country we're defining. Then we'll manually fill them up based on the division defined by the American government. For details on how we chose which region each state belongs to, you can follow the link below. Next up, we need to use npwhere for each region. Just like we did with loan status, we'll use the isIn function to check whether the values in the column are part of states west and assign a 1 if so. Then we'll check for states south and assign a 2, and so on. Afterwards, we'll call the unique function to check if we've been successful. The output includes the values from 0 to 4, saved as text, so everything appears to be correct. Okay. At this stage of our work, we've converted whatever string data we had into numeric values stored as text. To proceed with further tasks, we need to have converted them into a data type that NumPy will recognize as numeric. We'll see how to do so in the next lecture. See you all there.